Hello, everyone. Okay, so we're finished with the book, and by now you know, seniors, you guys are going to turn in your books on Monday. Juniors, you're going to turn your books on Tuesday next week, okay? So, hey, we're doing derivatives, and yeah, there's some stuff in our book about this, but I'm just going to show you some of the basics today. Just take some notes, and then there won't be an assignment today, but I will give you some problems tomorrow to do, okay? And so hopefully this will not take that long. Okay, so derivatives is like the next step. So you've learned a lot. You've learned a lot of algebra. Algebra 1, algebra 2, algebra 3, basically, trig, pre-calc, geometry, and then calculus. So this is the next step. It's not for everybody, but this stuff is pretty easy that I'm going to show you today. Um, I'm not going to go into the meaning of a derivative just yet or the usefulness of a derivative just yet. I think maybe tomorrow I will before I give the assignment. But here we go. So there's some rules for derivatives, and the first one says this: the derivative of a constant, which is just a number, equals 0. Okay, so you would say dx. That's the symbol for derivative. So if I said, hey, what's the derivative of 7? Well, the derivative of 7 is 0. Okay, if I said, hey, what's the derivative dx? There's other symbols also, but I'll show those to you later when we talk about functions. Dx of like pi. Oh, well, pi is still a number, and the derivative of it is 0. Okay, so another one, dx of e, because that's a number. Well, that's 0. Okay, so that's the first rule. The derivative of a constant is 0. It doesn't matter how big or how small, positive or negative, like I could change this to -7, and the answer would still be 0. It's all 0 when it's just like that. So that's rule number 1. You can pause it if you need to, but that's pretty doggone easy, right? Okay, next. Rule 2. So did I say this was rule 1? No. Okay. So rule 2 just says that whenever you take the derivative of, let's say, something like x to the 7th. Okay, so let's say anytime you take the derivative of something like that, here's what you do. Here's what you do. You do 7x to the 6th. What? So here's the dealio. If I said, what's the derivative of, let's do x to the n. So in general, it would be n times x to the n minus 1. In other words, this number goes out in front, bloop, and then you just subtract 1. Okay? This number goes out in front, and then you subtract 1. So if I said, hey, what's the derivative of, I don't know, x to the 100th, that would be 100 x to the 99th. Okay? Got that? But wait, there's more. What if their power was negative? So let's say it was d dx of x to the -2. You're like, what? That would be -2 x to the -3 because you still subtract 1 from that power right there. Okie dokie. And it can be decimals, it can be, positive numbers, it can be negative numbers, obviously. It can be fractions, it doesn't matter. You always take whatever this power is, of the original, it goes out front, and then you subtract 1 from it. Got that? That's rule number 2, and you're thinking, these derivatives are pretty doggone easy. Yeah, they are. And then the third rule that I'm going to stop with today is something called the multiple rule. And the multiple rule says something like this. Okay, now let's put in something like 5x cubed. Okay, well, the 3 still has to go out front, but you multiply by the 5. So this would be 15x squared. Okay, or if I said, what's the derivative of negative 7x to the negative third? Well, that would be 21, hello, x to the negative fourth. Negative 3 times negative 7 is 21, and then you still subtract 1. Okay? So we're going to stop the video there, less than 6 minutes. No assignment today. I'm going to show you guys the division property um, and some type of products rule tomorrow, and then we'll have some type of derivatives, just basic derivative stuff that you need to know. And with that, I say, good day.